Okay, in this lesson we're going to learn how to use Mathcad for solving problems numerically and symbolically, and we'll also learn how to generate visual representations, that means graphs of mathematical relationships. At the end of this activity, you will be generating an animation of an electromagnetic wave. Okay, so first things first, the very first skill you need to learn is how to enter text. Now, entries in Mathcad are called regions. So you have a Mathcad document just like you have a Word document. Entries in a Mathcad document are called regions, and there's one type of region is just a plain text. It just shows whatever text you type. Mathcad doesn't do anything with it other than display it. So to enter a text region, you type a double quote, okay? Or if you type something that cannot be interpreted as a mathematical equation, the first time you hit the space bar, it becomes text. Mathcad interprets it to mean that you want to enter just a plain text. So let's do this first. Let's enter a text box with your name about an inch from the top, centered on your Mathcad document. So I have the Mathcad document right here. Right, so I'm going to center it. I'm going to enter text here, so I'm just going to press. Let me see if I can pull out the keyboard so you can show what I'm pressing on the keyboard. So to enter text, you enter a double quote. So shift, okay, right here, double quote. So now you can enter, it's not entering it to Mathcad. Okay, but that's what you would do, shift, double quote. Okay, so double quote, and then, let's see, your name goes here. Okay. Oops. So you can move things around. Okay. What you do is hover over when you click on a particular region, it shows it in a box, and when you hover over it, you'll see a hand with fingers shows up that allows you to move the region around your document. Okay. So that's our first task. What else do we need to do? So let's drag the text box to the left margin at the top of the document. So let's do that right here. Okay. And the next thing we need to learn is how to define variables and functions. Defining a variable and a function simply means you're telling Mathcad how to calculate that variable or function. Okay, so the thing to do is to first type the name of the variable, and it must start with a letter or a Greek letter, and it can include letters, numbers, Greek letters, underscore, and subscript. Okay, and then you follow that by a colon, and when you enter colon, Mathcad responds with a colon and then an equal sign. So you don't type the equal sign. Mathcad automatically puts the equal sign once you type colon. Okay, and then you type the expression that you want to assign to that variable, and then you press enter. Alright, so let's look at the examples below. Let's define these expressions right here. Okay. Okay, so let's define, let me make this smaller. Okay, so let's define C, and then colon. If I type colon, you'll notice Mathcad responds with colon and an equal sign, and then I'll enter the value for C, 2.99792458 times 10. Okay, so to do times, press Shift 8. Okay, so to do times, you press Shift 8, which is an asterisk. Okay. And then 10 raised to the power 8. So to raise something to a power, you press Shift 6. Okay, Shift 6, that's a caret right there. So you press that, caret, oops, 6 raised to the power 8. Now everything you type after that will stay in the numerator, in the exponent. So to get out of the exponent, you press the space bar. Okay, the space bar on your keyboard is this thing right here. Okay, so space bar times, and then you enter the unit meters times seconds raised to the power -1. Okay. Now, alternatively, what you can do is you can insert unit. So you go to the menu, insert unit, and you know meters a unit of length. So you search for length, and meters is right there. So you hit insert, that will insert it for you. And keep in mind that if you have multiple units, they're all really meant to be multiplied together. So if you specify another unit, so you say times, that shifts 8 seconds raised to the power -1. Okay, or you can type, if you want, you can do slash. The slash key is this key right here on your keyboard. Okay, if you want to put your other unit in the denominator, maybe for a second, you can do it that way. Right? So let me just type it the way I had it in my instructions. Let's type it that way. Let's define h. H colon, that will give me an colon equal sign. 6.626 times 10, oops, times would be shift 8, 10, and then exponent would be caret, shift 6, -34. To get out of the exponent, space bar, one more time, space bar, times the unit, joules, times second. And then nanometers. Okay, Mathcad doesn't know what a nanometer is. You have to tell it what it is in terms of a meter. So nm colon equals 10 raised to the power -9 space bar times meters. Enter. And let's define electron volts. EV colon, that would be 1.602 times 10 raised to the power -19 space bar times joules. Okay, and let's define lambda. This one, lambda right here is 250 nanometers. Lambda, to get the Greek letter lambda, press the letter L and then hold down the control key while pressing the letter G. That's control G to make it Greek. So control G, that makes it Greek. Okay. Now, alternatively, you can pick up from your toolbar. You can view your toolbar right here. You can have the Greek toolbar, and you can actually just pick up the letter that you want, lambda. Colon, 250 times nanometers. And Mathcad, you'll notice here shows this in red. It's complaining that the variable is not defined above. The reason is Mathcad goes through your document from top to bottom and from left to right. And at this point in the document, you'll notice this expression, this region is above where you have defined nanometers. So by the time Mathcad gets to this part of the document, you haven't defined nanometers yet. So what you can do is you can drag it below, and you can see Mathcad's okay with that now because nanometers already been defined. If you want to move it above, you'll find Mathcad doesn't know what a nanometer is. Okay. Now if you want to line things up, okay, let's say I move this one over here. It's all messed up. What you can do is you can highlight the things that you want to separate. You go to Format, Separate Regions. Okay, now if things are not lined up properly and you want them lined up correctly, what you can do is highlight the stuff you want to line up. So you go to Format, Align Regions, and then align them down. Cross means line them up from left to right. So like if this one was over here, okay, and you want to make sure that they are aligned. See that this one's above this one. You want to make sure these two are aligned. You just say Format, Align Regions across. So now they're lined up. So this one shows up to the left of that one. So nanometer is defined before you actually use it. How do I enter the Greek letter phi here? Insert, you need to pull up the Greek toolbar, phi, that's phi, or you can just enter the Roman equivalent for phi, which is f, lowercase f, and then hit Control G, and then colon, oops, sorry. Part of the name here is a subscript, surface. So to enter a subscript, you press the dot or period. So dot is right here, okay? This one right here. So phi dot surface, you'll notice surface is written as a subscript, and then colon. Okay, I want to define that as 1 electron volt. So I'm going to say 1.0 times EV. Now it doesn't know what EV is because this apparently is above the definition of EV right here. So if I align these two, format, align regions across, so now this one is to the right. This expression for phi surface is to the right of the definition for electron volt. Okay, now what if I were to type capital EV? It doesn't know what capital EV is because Mathcad's variable names and units are case sensitive. So it has to be, if this is lowercase, uppercase, it doesn't, capital EV is not defined at this point. So make sure you enter things exactly the same way if each time you use it. Okay, so E photon, how do we do that? E, and to get to the subscript, you press period, and then photon, and then to assign an expression for E photon, you say colon, and then you say H times C, okay? And now if you press the slash key, that will just divide C. And it's okay because multiplication and division is commutative, and then you can enter lambda. But if you want H, for formatting purposes, if you want H and C to be both in the numerator, what you can do is press the space bar. So this pressing the space bar adjusts what we call this this selection cursor right here, this blue line, this blue line right there. So now that HC is selected, when you press the slash key, then H and C will be placed in the numerator. So slash, that puts H and C in the numerator, and then lambda is L Control G. Okay? And then finally, let's write an expression for a function. Okay, so now I can say, I can do KE underscore of underscore electron, open parenthesis, lambda, Control G, phi F, Control G, phi surface, so period, to get to the subscript, surface, and then close parenthesis, and then if you want to assign a value to that, you press colon, Mathcad responds with colon equals, and this thing right here, by the way, this black square that you see is called a placeholder. That's Mathcad expects to see that. Mathcad expects you to enter something there. So before you are able to enter anything there, Mathcad puts it there. So that's called a placeholder. H times C space bar over lambda. So L Control G. Now, everything I type from here on will stay in the denominator. So if I want to get out of the denominator, I have to press space bar. Okay, minus phi, so F Control G dot surface. Okay, and you have to press enter. That just completes the expression. So this is a mathematical expression, an assignment to a variable name or a function. Okay. Alright, so let's continue. Okay, let's just review. How do you do the following? How do you do multiply? Press Shift 8, right? The asterisk. To divide, use the slash key. To get out of the denominator, use the space bar. To enter an exponent, caret. To get out of the exponent, you press the space bar. Enter a subscript, you press a period or dot. To enter a unit, you just multiply and then enter, and then it will give you a Mathcad response with a dot and a placeholder for your unit. Okay, and then you can insert your unit there, or you can type it in. To do the Greek letter, you pull the Greek toolbar. Okay, click it on the toolbar, or you press the letter and then Control G. So that's how you would enter expressions in Mathcad. All right, so let's take a look now at what we can do after we've told Mathcad what the values of expressions are. So if you want Mathcad to display the numerical value of variables and functions, simply type that variable, then this time you type the equal sign. So when you type the equal sign, it's like saying, Mathcad, tell me what that thing is before the equal sign. So Mathcad will immediately respond with the value and the unit, if any. Okay? So let's go to our Mathcad document. So right here, if I've defined C over here. So if I ask for Mathcad for what C is, I'm going to say C and then press equal, and it responds, tells me it's 2.998 times 10 to the 8. Right? Now, meters per second. I can change the unit I want. If I want it in feet per second, I say I want it in feet. It will make the adjustment. It says hertz feet. Of course, hertz is per second. Right? So if I really want it to show us per second, I have to show it that way, feet/second. So it's 9.836 times 10 to the 8. Now you can format the way Mathcad shows your values, displays the numbers by clicking on Format over here, Result, and then say the number of decimal places you want, and then if you want to show trailing zeros. Okay, so generally you probably should check this Show Trailing Zeros so that it shows the actual decimal places. Now, if let's put this back in meters per second. Let's say I wanted to show just 2 decimal places. Okay, and if I don't show trailing zeros, it will show 3 times 10 to the 8. Why is that? 2 decimal places would be 3.00, but it's not showing the trailing zeros. So if I want to insist on those 2 decimal places, even if they're zeros, I have to show trailing zeros right there. Now, what about the value for, now look what happens if I move this above. Now it doesn't know what C is because C was defined after that. So if I line these 2 up, I can format, align regions across, now it knows what it is. Okay. Oops, what happened? 3 times 10 to the 8 meters per second. Now what about H? H equals, I'll define H. So if I want Mathcad to tell me what H is, I'll say H equals, and it gives me 0. Why is that? By default, Mathcad shows anything that is less than 10 to the negative 15, and what you have here is 10 to the negative 34. So that's less than 10 to the negative 15. Anything less than 10 to the negative 15 is shown as 0. Okay, so if you want to lower that threshold, okay, click out of any region. Make sure you're not on any particular region. So you go to Format, Result. Under Tolerance, you want your 0 threshold to be less than 15, but bigger than 15. Okay, so if you want it to show anything, like if you set this to 300, it will only show a 0 if the number is less than 10 to the negative 300. Okay, so that's a good number to use. So it's still that's your H. And if I want that in joules second, I can type joule, and you can say it's joules seconds right there. All right. So what's nanometers? Nanometers equals 1 times 10 to the negative 9 meters. What is lambda? Lambda equals 2.5 times 10 to the negative 7 meters. Okay? Which is 250 nanometers. Automatically makes those unit conversions for you. So if you want it in inches, let's see, what's the unit for inches? Inches, so you want length. If you want your length in inches, so the unit is IN. Insert that, and that's the answer in inches. Okay? So let's change that back to meters. You can also scale it. So for example, if you wanted to multiply that by 10 to the negative 9, oops, negative 9, spacebar times meters, it automatically adjusts the number so that when multiplied by whatever you typed in, it gives you the actual value. 10 to the negative 9 meters, as you know, is a nanometer. Okay? What if I want it to be short as times 2 meters? Then it says 1.25 times 10 to the negative 7 times 2 meters, because 2.5 times 2, 1.25 times 2 will give you 2.5. Okay, of course, that's something you'll hardly ever need, but that's something that's good to know. Okay? Okay, now, what is E photon? It's equal to H times C over lambda, and it gives it to you in joules. Okay? So it plugs in H, C, and lambda. Now, if I drag this above, it won't know what to do because E photon, as of this point in the document, has not been defined yet. So I have to move it after. Okay. Now, if I want my answer in electron volts, I can just say EV, and it gives me that for a wavelength of 250 nanometers, the energy of the photon is 4.96 electron volts. And again, if I move this above, it hasn't been defined yet. Let me see. It doesn't know what it is. Alright, so what else do we need to do? Okay, so let's see. By default, assumes a threshold of 10 to the negative 15, okay, for 0. So let's set that to 300 to make it display smaller numbers correctly. And like I said, you can specify the unit, and you can also specify a scaling factor by entering them in the placeholder. Okay, the number format, you can specify that by going through the menus. Okay, now when you're evaluating functions, you need to specify the values of the variables inside the parentheses and or define them prior to displaying the value of the function. So these are the expressions we have. So if, well, let's say I wanted to know what's the kinetic energy of the electron for the currently defined values of lambda and phi surface, it should give me 3.96 electron volts. Okay, so let's see. KE underscore of underscore electron, open parentheses lambda, oops, lambda, comma, phi, control G surface, equals, it tells me that's the value in joules, or in electron volts, is 3.96. Why is that 3.96? Because we did the substitution here, which is 4.96 electron volts, and then for phi surface, it was defined as 1 electron volt. So 4.96 minus 1 is 3.96. Now, I can have it calculate KE of electron for some other values of lambda and phi surface. I can manually override these values. So I can say KE of electron, okay, let's say for 500 nanometers, comma, phi, let's say for, what values did I have? 0.5 electron volts, for example, 0.5 electron volts equals, and you can see that's the answer in joules, or in electron volts, it's what, 0.98 electron volts. It made a substitution of 500 nanometers for lambda and 0.5 electron volts for the phi surface. Okay? What if I ask for the value of lambda? Lambda equals, it's still 250 nanometers, okay? Even though I've overridden it in this expression right here. By doing it here, you're not changing the value, the currently defined value of lambda. Incidentally, if you do change, you can reassign values for variables. So I can redefine my lambda, let's say, to 300 nanometers. After that, lambda is now 300 nanometers. Okay, so anywhere in your document, you can redefine values for your variables. few things to note about variable names. Okay, all variable names must be defined before they can be used to define other variables. I've already illustrated that. Mathcad is case sensitive, so for example, if you define volume with uppercase V, you cannot use lowercase v to refer to that volume. Okay, so it's case sensitive. And be sure to remember if you use the letter O or the number 0 when defining variables, because that would lead to confusion. Later on, you might have a hard time tracking down where the problem might be. Put a text box reminder next to your definition to remind yourself whether you were using a capital O or just the number 0. Another thing to worry about variable names in Mathcad is avoid those that are predefined in Mathcad. For example, M represents, if you use M to represent mass, that's not a good idea, because now you won't be able to use it for the unit meter. Okay, you basically redefine the letter M, and so make a habit of verifying whether something is predefined in Mathcad, so it will save you a lot of headache in the long run. To verify if something is predefined in Mathcad, type it and then type an equal sign. If it's predefined, it will give you a value. Okay, so for example, if I type pi, Control G, equals, Mathcad knows what it is. Okay, I haven't defined it anywhere in this document, but now let me see it. But you can override that definition. If you don't ever plan to use pi the way it is defined, you can redefine it and let's say pi equals 25. And now if you ask for pi, it will say pi is 25. Okay, so you can redefine predefined variables, and that's usually not a good idea unless you really have no intention of using the predefined values. Now, one particularly annoying definition of Mathcad makes is G. G, if you look at type G, G is equal to 9.8 meters per second squared, acceleration due to gravity. Since we use G a lot for grams, okay, gram is actually, in Mathcad, it has to be entered as GM. But if you don't ever intend to use the symbol G for acceleration due to gravity, okay, you can just define gram as G as gram. So now G is equal to 10 to the negative third kilogram, which is what it should be. Okay, and you probably want to use like A dot G, acceleration due to gravity, as G as 9.8 meters per second squared. Okay, so keep those in mind and make sure you verify. You can try some of these letters, see if they are predefined or not. And like I said, variables can be redefined. You should avoid redefining predefined values unless you never plan on using the predefined value. All right? And also, you can only add or subtract units, quantities that have the same units. So, for example, if you do KE of electrons and you don't specify units for 500 and 0.5, look what happens. Let's see. Mathcad expects to see a quantity that has length here and a quantity that has energy there. So if I type KE underscore of underscore electron 500.5, I type enter, Mathcad doesn't know what to do. Why doesn't it know what to do? Because if it plugs in 500 for lambda with no unit, okay, H has been defined with a unit, C has a unit, so this will have a unit, and phi surface is 0.5, it has no unit, you define it as 0.5, no unit. So this expression right here on the left, this one has a unit, this has no unit, Mathcad doesn't know what to do with it. Okay? Okay, so today we're going to learn how to create an animation using Mathcad. Okay, we're going to animate the electric field wave for an electromagnetic radiation. The function for the electric field as a function of time, and we're going to simulate, okay, we're going to simulate an electric field traveling, okay, towards the positive z-axis direction. Okay, so it's a function of z. And so the expression is the electric field is equal to E naught, the amplitude, times cosine 2 pi t over tau. Tau is the period, the time it takes for one cycle to complete, minus 2 pi z over lambda. Okay, it's you can also call this 2 pi nu t. Remember, nu is 1 over the period, right? Minus 2 pi z over lambda. Okay, but we're going to define it like this. So what are we going to do? First of all, let's go ahead and define this, type up this expression. So we're going to say, let's see. E as a function of t comma z, and assignment operator, what do you do? Question? Okay. Okay. Press colon. E, how do you do a subscript? Dot O, right? Period. Okay. And I'm using the letter O there, not 0. Okay. So I'll make a note here. E naught has subscript lowercase o. Okay. Not 0. That's just so I'll remember. So it's going to be E naught, okay, times cosine of 2 times pi. How do I enter pi? Greek letter. So right here, pi times t over tau. Tau is t control g. Okay. How do I get out of the denominator? Space bar minus 2 times pi times z. And then how do I put 2 pi and z all in the numerator? Space bar, and then how do I divide? Slash. Okay, lambda. It's L control G, or you can pick it up from your Greek toolbar, and then close parentheses. So there's your function right there, and Mathcad's complaining. Make this smaller. Mathcad is complaining it doesn't know what lambda is. So I have to tell it what lambda is. So let's just say lambda is, we have to define lambda. You're supposed to define lambda as 500 nanometers for this example. So let's define lambda first before that, right? So lambda control G colon 500 times nanometers. And it's complaining it doesn't know what a nanometer is. So what do? Define nanometer as 10 raised to the power negative 9 meters. So it now knows what lambda is. Okay, hold up, I'll pause this. It doesn't know what tau is, right? Or what? Tau, I'm sorry? Oh, that's Greek letter for T. So it doesn't know what tau is, so what do? You define tau above it, right? What is tau? The period is 1 over, oops. Tau is T control G, colon 1 over the frequency, right? Frequency is nu. So nu and control G is frequency. Well, it doesn't know what nu is. So what do? We define nu. What is nu? Nu is c over lambda, right? Frequency is speed of light divided by lambda. Well, it doesn't know what c is. So we have to define c before that. So let's define C. C colon, what's the value of C? 2.998 times 10 raised to the power 8 space bar times meters slash seconds. So now it knows tau, it knows lambda. The only thing it doesn't know now is E naught, the amplitude. That's not the letter V, that's the Greek letter N. Nu. Greek letter N, nu. N, and then hold on to control key and then G. Control G, make it Greek. Yeah. When you type a letter and then you hold on to control G, then you're making the letter Greek. Or you can just pull it up from your Greek toolbar. Okay? So I'm going to move this over here. So I'm going to line these up. Format, align regions across. Format, align regions across. Make it a little neater. Line these up. Okay, the only thing it doesn't know is E naught. So what's E naught? E naught is amplitude of the oscillation. And you're supposed to use value of 200 newtons per coulomb. Okay, so we're going to define 200 newtons per coulomb as our E naught. So E subscript, period, lowercase o, colon, defines E naught 200 times newtons per coulomb. Okay, just to make sure you have the right unit, using the right symbol, you can go to the unit toolbar, the unit menu, and you can say capital N is newtons. Okay, so unit of force. And C, go to the unit toolbar just to verify that that's coulomb. It is coulomb. Alright, so now it knows everything that it needs to calculate the electric field wave. Right. So what do we do now? Let's plot that. How do I plot it? I have to define a range of values for my independent variable to plot. So according to the instructions in your handout, we're going to plot from T. We're going to define T as 0 times tau. Okay. So let's see. T is equal to 0 times tau. So T is 0 seconds to begin with. Okay. And we are going to define, we're going to calculate our electric field versus Z from 0 to 5 lambda in steps of 0.01 lambda. So I'm going to define Z as a range variable. So I'm going to say Z starting from 0 times lambda. Oops. Okay, up to 5 times lambda in steps of how much? 0.01 lambda. So the first number is 0 times lambda. The second number in the range is 0.01 times lambda. And then how do I specify what the ending value is? Semicolon, and semicolon shows up as 2 dots, 2 periods. And then at the last number I want for my Z would be 5 times lambda. So that means I'm going to show 5 cycles of my wave. So 5 times lambda. Okay, make sure all of these numbers have the same units. Okay, common mistake is to just type 0. It's best to express it make all your numbers have the same unit. So if I type Z equals here, you can see all the possible values for Z in meters. Okay, so Z, if I want it in Z equals, I can specify nanometers here if I want. You can see 0, 5, 10, 15, 20, all the way to Z equals. It will tell you what the values of Z are. And then if you click on it, you can see it's got a scroll bar. A scroll, yeah, that's what it's called, right? A scroll bar. And it goes all the way to 500 nanometers. Okay, so starting with 0, that's 0.05 nanometers, 0.1 nanometers. If this was nanometers, 5 nanometers, 10, 15, all the way to 500 nanometers. Well, all the way to 250, 2500 nanometers. Okay? So that just verifies that those are the values of Z. I don't need that listing actually. So what do I do now? I can graph it now, right? So insert a graph, XY plot. So I'm going to plot versus Z. Okay, I can do this in Z over nanometers if I want, and I want to plot E of T Z. And there's your 5 cycles right there. So let me plot this instead in terms of lambda. Okay, so let me format my graph so that I have I have 5 grid lines on my x-axis. Nope. Yeah. And then over here I can specify what my maximum is. So I specify 5 lambda right there. So you can see, oops, sorry. You have 5 cycles there. There's 1 cycle, okay, the 2nd cycle, the 3rd cycle, the 4th cycle, and the 5th cycle. I'm sorry. Double click on the graph and then specify how many, if you want, you can specify the number of grid lines, number of grids if you want. There, so and that's 5 grids. Okay, so I can change this one to, let's say I want it to go from negative 250 to 250. Oops, negative 250. Oh, by the way, my electric field, I need to specify that, divide that by the unit, which is, what's the unit for electric field? Newtons per coulomb. Okay. Just to avoid any problems later on.
Stop it at 5 and then get the equilibrium.
Oh, if you click on it, you can click here, specify what the maximum you want. And you click here, you can specify what you want for the maximum. And over here, you can specify what your minimum and maximum value is. Oh, if you double click on it, you can check grid lines. Uncheck grid lines, apply, it goes away, check grid lines, apply, it goes back. Okay, you can do the same thing for the y-axis if you want. All right. So that is the electric field wave at time equals 0. I define t to be 0 times tau. T is 0. Yeah, it is 0. Oh, this one right here? Once you've defined it, you can ask Mathcad to tell you what it is. So you say t equals, and it should show you just t equals 0. Now, if it doesn't show the unit, that means further up, you did not define tau correctly. So that's a quick way to check if you have problems with your units.
Go on for just a second.
Sure. Let me pause this for now. Okay, so continuing on. Let's see what happens to this if we advance time. So let's advance our time, okay, to, let's see what happens at e of 0.0, when t is 0.1 times tau. So instead of t, I'm going to put 0.01 times tau, z, okay, over newtons per coulomb. And you can see what happens there. The blue curve, you can see your wave has moved, right? The red curve, and then a tenth of a period later, it's already advanced. A tenth of the way towards the next, where the next cycle will begin. Okay? How do I click there? Okay, let me go back. Hold on. Okay. So here, that's the graph we had before, right? Click on it, and then make sure that this blue thing, this blue line is facing to the left. Just hit spacebar until you got the whole expression selected. Then press comma. Comma will allow you to enter another thing to graph. So this time I'm going to type E, open parenthesis, 0.1 times tau, comma Z, over newtons per coulomb, and you can see that's what happens. What will happen if I make it 0.2 tau? It advances further. 0.3 tau, it goes even further. 0.4 tau, even further. 0.5 tau, it's halfway. So you can see it's a traveling wave. As time advances, your wave moves up. Actually, what's going on there is the electric field in a given location is actually just bobbing up and down here. So it appears as though the wave's moving. Okay? So, let's see. Okay, so just remove the second graph that you added and make it look like this again. What we're going to do now is to do an animation. And so I'm going to put t over here. I'm going to define t as frame times 0.1 times tau. Okay, I'm going to redefine t to be frame times 0.1 times tau. So that word frame is all caps. All right, so I have defined t as frame times 0.01 times tau. Now, this number frame, by default, that number is just 0. That variable is predefined to be 0. But that is used in Mathcad to generate an animation. So basically, you tell Mathcad how many frames do you want for your animation. Each snap, like a movie is just a series of pictures. Each picture is a frame. Okay? So when you generate an animation, Mathcad will ask you how many frames do you want, and how fast do you want these frames to show up when you do the animation. So what you can do is, once you define that, see what happens is as the animation advances, that frame goes from 0, 1, 2, 3, 4, 5, 6. So if this variable frame advances, then time will be advancing, right? So if you're plotting something that depends on time, then this graph will be changing during as the frames advance. Okay, so what I'll need to do, okay, is go to View, Animate. Okay, and you specify how many frames you want. Let's say we want to make 100 frames, and you want to see 10 frames per second. Okay, so you specify that, and then you click out of your animation dialog here and highlight the part of the document that you want to animate. So you highlight this part. I want to see how this part of your document changes as the frame advances. And so what I do now is I click animate, and you can see there it generated the animation. And so if I play it, and there's a moving wave right there. This is 100 frames. Okay. I had from 0 to 100, 10 frames a second. If I want a slower movement, I can maybe do 3 frames per second. Okay, and then I'll hit highlight this part of my graph, and then hit animate again. This is 3 frames per second. Now, if I want a finer, advancement in time, so I want to advance just 0.01 tau at a time. And just so you can see what the actual time is, let me move this up. I'll put the value of time here, okay? In terms of tau, okay? So I go to View, Animate. I want to do 100 frames at 10 frames per second. And I want to see this. And hit Animate. And look at the time right here when it's when the wave is moving. See, as time advances, you can see your plot changes. Okay. All right. So now that you have your animation, you can save your animation over here next to the play button right here. Click on that. You can there should be a place to save it. Copy? No? There should be a way to save this one. Open? No? Yeah. Open. No, that's not it. All right, so from the animation toolbar, animation dialog box, you have a save as option. Okay, so if you hit save as, you can save your animation. It's an AVI file. So let me just put this in the desktop on my folder here. So EMWave, and the default extension is AVI. Hit save. Okay, so now when you get out of Mathcad, if you go to that folder, there's the EMWave file. It will just play it right there. And then you can send that up to YouTube. Okay. For your post-lab activities, there's a couple of animations I'd like you to make. I want you to send those up to YouTube. Set your settings on YouTube to be unlisted, and then send me the link. So you and I will be the only one to see it if you don't want to broadcast it to the world. Okay. All right. For this lab activity, you don't need to send this to me or anything. But for the post-lab activity, okay, you are going to animate the black body spectrum as temperature changes from 5,000 Kelvin to 1,000 Kelvin, you're going to let it drop by 10 Kelvin at a time. And so you need to show a graph, an animation of that, okay? And I think you also need an animation in this case for the Wien's displacement law, how your
Oh, when exactly do we do that? Like during lab period?
during lab period. So this next couple of lab periods you work on this, and then you create your animation to submit.
Oh.
And then problem number 3 right here is just a calculation. Okay, we're going to talk about the de Broglie wavelength calculation of that in the next lecture. The lecture class. Okay, so this will complement what we're doing in the lecture. Right? There's a couple of things we need to do. A couple more. Let's see. So we've done animation. There's a couple more skills you need to learn how to do. Entering an equation in Mathcad. Okay. This one is if you want to enter an equation but you don't want Mathcad to do any calculation. Remember we said when we press colon, Mathcad replies with colon equals, and you tell Mathcad how to calculate something, right? Now if you just want to enter an equation and you don't want Mathcad to do anything with it, just display it, you hit control while pressing the equal key. So if I want to enter this expression right here, for example, okay? So I'm going to enter E naught. To enter this one right here, if I don't want Mathcad to do any calculation, I hold down the control key while I press the equal sign, and then I'll do square root of 2s over c epsilon naught. Okay, let me do that. So let me create a new document. So what was the equation? E naught. So E dot O. Let me make this big. So instead of equals or colon, I hold down the control key, this control key right here, and while pressing the equal sign, okay? So control key equal. You can see that equal sign right there is thick, okay? And then square root. How do you do square root? You go to your calculator toolbar. Okay, you can go view, toolbars, calculator, or this icon right here is a calculator toolbar. And there's a square root sign there. There's a square root symbol. Square root. Okay? Or if you want to use the keyboard, square root is backslash. On your keyboard, the backslash key will give you your square root sign. So what was the formula for E naught? It's 2 times s over c times epsilon naught. So I'm going to enter 2 times s space bar divided by c times epsilon control g, make it Greek. So E control G is epsilon, and dot O would give me that. Notice Mathcad is not complaining. It doesn't know what C is. It doesn't know what epsilon naught is. It doesn't know what S is, but it's not complaining. It's not putting it in red because I'm not trying to ask it. I'm not asking it to do any calculation. I'm just writing an equation. Okay? Let me see if you're all caught up. Okay, so everyone's caught up. So that is how you would enter an equation. Now, the nice thing about being able to do that is you can have Mathcad symbolically solve for your variables. Okay, so symbolically solving for a variable in Mathcad, you just click on the variable you want to solve, click on symbolics, and then click on the item that you use to solve for the variable. So let's say we want to solve for s in this expression right here. So what I do is here, I click on S. So right now I've selected S. I click on symbolics, variable, solve. And I just solve for S right here. This is my S. Okay, so I can just copy that. Okay, backspace. I mean not backspace. space bar, space bar, space bar, and then Control C to copy or Control X to cut or copy, okay? And then you can say S, Control equals, and then you say paste. Okay? So that's a very useful thing to know, how to do on Mathcad. Alright, so now let's take a look at another thing you can do with symbolics. Let's enter these equations right here. So we'll start with lambda equals h over p. So I'm going to say, what do I do? If I don't want Mathcad to do any calculation, lambda, how do I enter the equal sign? Control equal, okay? Or another way you could pick that up is over here. This one right here is a symbolic equal sign. Let's see, not that one. That's evaluation. The Boolean right here. The Boolean toolbar. That's the thick equal sign right there. That's a control equal. Okay? So, and what was our formula? H over P, right? And then equation 2 is mass times volume. So I'm going to say P control equals, or this one, mass times velocity. Why am I using MASS for mass instead of just letter M? Yeah, because I don't want to have to mess with meter and mass, getting all mixed up, okay? Especially when I have to use that formula later for calculations. And then what do I do next? What's the third equation? Equation 3. Okay, I'm gonna, okay, equation 3 is mass times mass naught times 1 over square root of 1 minus b squared over c squared. So I'm gonna say mass, control equal, mass dot O times 1 over, how do you do square root? Backslash, okay, 1 minus b squared over c squared. 1 minus v squared, to get out of the exponent, space bar, okay, divided by c squared. So that's equation 1, 2, and 3. All right, so now that you have these equations, let's do something called substitution. I want to substitute mass times velocity for p. Okay, so this is p, so I'm going to substitute for that one. So the way I would do that is I'm going to highlight mass times v, copy that, right-click, copy, and then I'm going to select p in this expression right here, and I'm going to go symbolics, variable, substitute. And what did it just do? It gave me an equation where mass times v was substituted for p. Okay, so let's call this equation 1, and this is equation 1a, and this is equation 2, and this is equation 3. So that's substitution. Alright, so what do we need to do next? Now we're going to copy the right-hand side of equation 3. That's expression for mass, right? And I want you to substitute that for mass in equation 1a. So this is your mass, right? Right-click, copy, and I'm going to substitute that for mass right here. So for this one, so I'm going to do symbolic, variable, substitute, and I just made the substitution right there. And so That is our equation 1b. Okay? Let's call that equation 1b. So that would be the relativistic formula to for the de Broglie wavelength, which we're going to cover in the lecture on, that would be tomorrow. Oh no, when's our next lecture? Friday. So that's how you do a symbolic manipulations. There's a lot of other things you can do with the symbolic process, so you can do derivatives, integrals. We're going to learn those throughout the semester. What I've taught you, at least for this lab, is this particular section, is just the basics. So what are the basics? How to define a variable, right? How to ask Mathcad to display a variable. How to define a range of possible values for a variable. How to define a function. How to plot a function. How to animate. And how to write an equation, symbolic equation, and how to do symbolic manipulations, particularly solving for a variable and substitution. So let's just try a couple of things before I let you loose on the rest of the problem. Let's say I have x squared, a times x squared plus b times x plus c. Control equals, that makes it a symbolic equal sign, equal to 0. Quadratic equation. I want to solve for x. What do I do? Click on x, symbolic, variable, solve. And there's your formula, quadratic formula. Negative b, okay, plus or minus square, this is the square root of b squared minus 4ac over 2a. Two possible answers. Either you add or you subtract. Neat, huh? So I think you should be able to do the rest of this on your own. That would be your post-lab report. Finish, do the problem here with the black body, spectral density function versus temperature and wavelength. And then the Wien's displacement law problem here. And something to do with the de Broglie wavelength. Okay? Where you calculate the de Broglie wavelength with and without, including relativistic effects, and you should be able to do that Friday after we cover that in the lecture. So that's it for this lab.